A single AI model now holds 10 trillion parameters, more connections than there are stars in 100 Milky Ways. Yet, right now, a single fire burning over the Persian Gulf is forcing the world to reconcile that digital scale with a fragile physical reality. In Manama, an energy analyst named Fatima watched her monitors flood with reports of drone strikes hitting Bahrain's Bapco storage facility. Within minutes, the local power grid began to flicker as two major plants were pulled offline. This complex is the lifeblood for 1.5 million people. In Bahrain, power isn't just about lights. It runs the desalination infrastructure that turns seawater into drinking water. If these chimneys stop smoking, the taps eventually run dry. The ripple effects moved faster than the smoke. Within hours, OPEC Plus had to raise production quotas by 200,000 barrels a day to stabilize a global energy market that was already pricing in the disruption. We are seeing a mismatch in speed. Our critical infrastructure is heavy and slow to change, while the drone swarms targeting it are cheap, asymmetric, and move at the speed of software. The primary bottleneck isn't the thickness of the steel on an oil tank, it's the speed of our planning. Traditional defense models require weeks of human analysis to react to a new type of threat. A modern utility grid has millions of interlinked variables. Mapping out a new defense strategy in the 4 hours between the first strike and the second is currently impossible for human teams. Our vulnerability is defined by a deficit in response latency. We are struggling to plan as fast as the world is changing. While those physical systems were under fire, engineers like Marco were completing the final training run of a different kind of defense. Anthropic just released Claude Mythos 5. It is the first model to reach a 10 trillion parameter milestone, specifically tuned for high-stakes research and cybersecurity. To understand this scale, look at how Mythos 5 compares to previous models. This order of magnitude increase enables multi-step consequential planning. It models the branching outcomes of complex decisions, looking moves ahead to see how a change affects the system. This is an agentic reasoning engine. It can take a raw schematic of an energy grid and simulate how a specific physical attack might cascade through the network. Reaching 10 trillion parameters shifts the model's primary output from text to engineering. It calculates the physics of a power surge or a valve failure to propose a concrete physical defense. In London, a researcher named Priya is already putting this to work. She's using the model to map out every possible threat vector for a national energy grid. Priya's team is simulating thousands of drone swarm scenarios in a single afternoon. Work that used to require a government agency and 6 months of manual data entry is now happening in hours. This same capacity is available to Adeze, a student in Lagos. She's using the model to design resilience frameworks for West African water systems, ensuring local grids can survive the same kind of disruptions we saw in Bahrain. The asymmetry has flipped. A single researcher, or a graduate student, now possesses strategic planning capacity that used to be reserved for the world's largest intelligence agencies. In a Gulf Operations Center, these two worlds are finally meeting. An operations lead named Khalid is watching the Bahrain attack data stream in real time. On the left, raw drone strike data. On the right, the model organizes the chaos, projecting defensive barriers around critical nodes. Zooming into a desalination node, it outputs 3 hardening measures, like flow bypasses, keeping water moving if a tank is lost. The physical chaos of the Persian Gulf is being analyzed and resolved by digital intelligence as quickly as the threats can emerge. These energy grid attacks function as a systems stress test. They reveal exactly where a network is weakest, providing the data needed to tighten the loop between a strike and a deployed patch. The world isn't just becoming more dangerous, it's becoming more manageable. Every day, people like Khalid, Priya, and Adeze are using these tools to turn a moment of vulnerability into an upgraded, more resilient system. If 10 trillion parameter planning is now accessible to everyone, the advantage shifts to the builders. So what are you going to build to make your corner of the future unbreakable?